Hello and a warm welcome to you all. My name is Vanessa Johnson, and this is going to be a series on basics of remote sensing and geographic information system. This is a very basic course. It's great for all the beginners out there. Also, if you want to go on your basics or your fundamentals again, this video is the one for you. So moving on, this video is going to be an introduction to GIS, the definition of GIS and the stages of GIS development. Moving on to the definition of GIS, a geographic information system is a system designed to capture, store, manage, analyze and present spatial or geographic data. So a term or an abbreviation that I like to use is CS map. I call it CS map because it's easier to remember. Capture, store, manage, analyze and present. What are we presenting? We are presenting spatial or geographic data. That is why it is called GIS and not just IS, that is information system. So since we are only looking at geographic data, it is known as geographic information system. Again, as I mentioned, we are going to be using computers because it is an information system, and what GIS basically does is that it gathers the various information. So again, going back to CS map, capturing, storing, managing, analyzing and presenting what? We are presenting geographic data. This is done with the help of computers, with the help of satellites. We will be discussing remote sensing in the further videos, and basically what GIS is that once we gather all of this data, when we have this on a computer, we create various layers, as you can see in the images here. When we create various layers, for example, this layer is water, this one may be agriculture, this one may be settlement. So when we create such layers, we can then integrate these layers, make them into one, which will form our main or like our major map later. So this is Roger Tomlinson. He is referred to as the father of GIS, and he has also given us a definition. His definition says a geographic information system is a computer based tool for mapping and analyzing things that exist and events that happen on Earth. GIS technology integrates common database operations such as query and statistical analysis with the unique visualization and geographic analysis benefits offered by maps. So we're going to do a bit of the history. Where did GIS come from and what has Roger Tomlinson to do with it as we go ahead. The stages of GIS development and a historical background of GIS development, it is very crucial for us to remember that before digitization, before computers ever existed, everything was done manually with hand, and the ancient civilization or ancient times, people used to carve out on inside caves, on rock structures, etc. As man evolved, we started using leaves, and as we evolved even a bit further, we started using paper. So paper, the issue with paper is that to make one map takes a long time. That map which is created by hand cannot be copied very easily. Also there can be some mistakes that can be made on those maps, and it is very difficult to transport or to share that map. So basically the feasibility with manual maps or with manual cartography is very less, and that is why we have developed. But the initial phase of GIS development was done on a manual map. So it was done by Dr. John Snow, and he is known as the father of epidemiology as well. He was living in London around 1849, and at that time there was a disease which nobody had seen before. All they knew were the symptoms of the disease. So it had diarrhea, vomiting, fever, and all these people randomly were coming to the doctors with such symptoms. So these doctors had no clue as to what disease this is and how is it spreading, what is causing it, etc. So Dr. John Snow, what he started doing is he found out exactly where these patients or the people affected by the disease were staying, and he marked it on a map. So that's the map that you can see in front of you, the images. And he made a dot map to show exactly where the people who were affected by this disease were living. And he found out that these people who or these patients who he identified were all living close to water lines or water pumps at that time. And that is how they came to know that this disease, which they later named as cholera, spreads through water. So this is an original map that is made by Dr. John Snow, and it shows the cholera cases. You can see all the cases, they are almost linear, and they are linear to water pumps or water lines that were there at that time. And basically at that time, all he was trying to do was trying to map something, but that mapping has shown us that how GIS can be a problem solving tool, and how we can still use it today as well. The GIS dark ages. So this is basically before 1960s, where there were no computers, there was no digitization, there was manual cartography, that is map making by hand. And this map making by hand is quite difficult because to make one single map used to take them hours, days, months together at a time. And also to distribute these maps, to share the map, to copy the map, it was really a hassle, and it wasn't easy to do any of this. There was also something called as sieve mapping at that time. Sieve mapping is basically you take transparent layers or transparent sheets of paper, and you use light tables, and you can make different layers or entities on each different map, and you can stack them together. An example of sieve map is given towards the right side. So for example, you have settlement, you have some contours, you have water bodies, agriculture, business or industrial areas, you have your roads and your transportation networks, and in the end you put all the sieves together or all the different papers together, you stack them up, and you get one final map. So this is a very tedious task, and it is simply very difficult and tiresome and not feasible. So people wanted to move on from the traditional way of making maps, and that is where GIS has come in. So from 1960s to 1975, there was GIS pioneering that was done. So Roger Tomlinson, the father of GIS, he's a Canadian. He's worked with the Canadian government, and he initiated, planned, and directed the development of the Canadian geographic system at that time. And also at this time, map graphics as outputs using line printers had started. There were advances in data storage. There was recording of coordinates as data input in computers. So this was just something new that has started with advancement in technology. Even technology was improving. It had also just started, but it was improving, and people figured that we can use or we can do mapping using computers. So there was GIS pioneering done around the world. So the US Census Bureau was an early adopter of some of the core principles of GIS. It was the pioneering work by the US Census Bureau in 1970 that led to the digital input of the census. And they at that time used something called as GBF, DIME. So this is basically geographic base file, GBF, geographic base file, and DIME stands for dual independent map encoding. So it's written here as well, you can take a note of it. And at that time, the Ordnance Survey of UK had also started using technology and computer to draw or to make their maps, their topographic maps. So as these countries started using GIS, initially it was used mostly by the government, and then it has moved ahead as well. So in 1975 to 1990, there was GIS software commercialization. So this commercialization was done basically after the Harvard laboratory computer graphics. They developed the first vector GIS called as Odyssey GIS. This was the first application that they've made, and there is a company, or there is a institution called as ESRI, and they are the major or the leading software makers for GIS, and they are still widely used today. There are multiple softwares that we can use today with the advancement of technology. Some of these softwares are free to use and available for all to download, such as QGIS, and some of these applications are not free and must be bought from the correct sources. Moving ahead, 1990 to 2010, so there was user proliferation. So basically what started happening is that users started to adopt GIS technology in different ways. So just rather than the government using GIS, GIS was introduced in classrooms and businesses, and there was digital mapping and analysis done widely. Basically the computers were cheaper, faster, and more powerful. They could handle larger data easily. There were multiple software options. There wasn't just one software in the market, there were multiple softwares which could be used. There was a lot of data that you could download, and that was freely available at that time. There were new satellites that were launched. These satellites were launched by various different countries, and the data was freely made available for the people to use. So this is where the users or GIS analysts or just common students like you have also come into the picture, where GIS has just had a boom. So the history of GIS is basically in 3 stages. So it's the past, the present, and the future. So the first stage is the pioneering and development stage that we spoke about. The next is GIS software commercialization, and then the third is user adoption that we spoke about. So this is quite relevant for you to remember. Another thing that I would like to add to this is the 2010 to today. So after 2010, what has happened is that there has been an open source explosion. So because processors are now in gigahertz, graphic cards are better than they've ever been before. We can use data in, and we can store data in terabytes. So it is much easier, much faster, and basically there are multiple satellites that we can use today. And so GIS has just gone from being it has just gone, and it has just become better over time, and there's been a huge shift in our usage of GIS. So the evolution of GIS in the 21st century, so the information management, back in 2000s, GIS evolved into a system of information management. For example, ESRI, the company that I had spoken to you about, ISRI developed its RDBMS, that is basically their database management system, or a geo database. So this was a game changer at that time, where they had a database management system specifically made for geographic data. Then in geography, GIS was not just a subject that was based on computers, but it is used in geography as well, where while managing the data, we still used geography or geographical aspects and the key areas of interest that we had. Then there is something called as geo design. So this did not happen until 2010. That geo design became ISRI's primary vision. So it basically rethinks how we inhabit the world by combining geography with design. So how we can combine geography, computers, and design together, so that comes under geo design, science of where. Although there is geodesign, GIS basically talks about science of where. So where different things are on the face of the earth, and their exact latitudes, longitudes, and it just opened up a lot of new possibilities, and it has just gone from being okay to much better, and it's just becoming the best now. So the intelligent nervous system is basically where we are right now. So it is 2020 and beyond, where we are using the internet so widely, and I'm sure that you all have Google Maps on your phones. You are constantly using location data. You are using so many things on a day-to-day basis that is coming from GIS. So every time you order something, maybe on Swiggy, on Uber, or whatever you do, wherever you place an order, you see a tracking device, you see where the delivery guy is at that time, and you can track that person. So all of this is done with the help of GIS. So I would just end here. Thank you so much for being a part of this video, for listening, and if you have any questions, please mention down in the comments. And also, I will be coming up with new videos to continue this series. Keep watching, like and subscribe if you like. Thank you so much for your time.